Today we're diving into the fascinating world of our brain's chemistry, a bustling metropolis where molecules like dopamine, serotonin, norepinephrine, and GABA are the real VIPs orchestrating everything from mood to motivation. Think of dopamine as a reward courier lighting up our brain's reward circuits, especially in areas like the basal ganglia, which helps us move, feel motivated, and even enjoy a good laugh. Meanwhile, serotonin is a mood stabilizer, calming the chaos and influencing everything from happiness to sleep. But hold on, these neurochemicals don't work alone. They interact through complex neurochemical mechanisms, shaping our thoughts, behaviors, and feelings. It can lead to neuropsychiatric disorders like depression, anxiety, or even schizophrenia when things go awry. For example, in depression, we often see a dip in serotonin levels or disruptions in dopamine pathways, which can dampen motivation and mood. Anxiety might involve hyperactive circuits in the anterior cingulate cortex, making us feel alarmed or aroused even when there's no real danger. Inflammation is a surprisingly important player in the story. Our immune system, through inflammatory cytokines, can influence brain function by mobilizing immune cells and activating pathways like the mitogen activated protein kinase cascade. This inflammatory response isn't just about fighting infections, it can affect mood and cognition too. Elevated cytokines can cross the blood-brain barrier and impact neurocircuits, sometimes leading to behavioral changes, seen in depression or even schizophrenia. Tryptophan, the amino acid precursor to serotonin, can be shunted into the kynurenine pathway during inflammation, producing metabolites that may influence neural function. Some of these metabolites can affect glutamate, our primary excitatory neurotransmitter. Think of glutamate as the brain's rapid-fire messenger, especially for synaptic plasticity and circuit connectivity. The brain's motor areas and reward pathways are heavily reliant on a delicate balance of dopaminergic, serotonergic, GABAergic, and glutamatergic signaling. For instance, the D2 dopamine receptor and dopamine transport regulate dopamine availability in the synapse, influencing behaviors like movement and motivation. In the realm of metabolic health, insulin isn't just about blood sugar. Insulin signaling in the brain interacts with neurochemical pathways, influencing neuroplasticity and circuit function. For example, hyperinsulinemia or hyperinsulinemia, conditions of too much or too little insulin, can lead to metabolic dysregulation. So, in summary, our brain's mood, condition, and behavior emerge from a symphony of neurochemical interaction, immune response, and metabolic processes. When these systems are in harmony, we feel good, motivated, and mentally sharp. When inflammation ramps up, our neurotransmitter systems go haywire. It can lead to mental health challenges. Thankfully, ongoing research into these mechanisms, like understanding the role of cytokine circuit connectivity and insulin signaling, brings us close to more effective treatments. Because at the end of the day, our brain chemistry is delicate dance, and understanding it helps us keep the rhythm going smoothly.